Example 1, sketch 2 comma pi over 4 and 2 comma minus pi over 4 in polar coordinates. Now let's start off with a little bit easier one, this one here. So we know that we want to rotate pi over 4 radians off of the positive x-axis. We know that that looks like the line y equals x here, right? And the only other thing we want to make sure is that we have a distance from the origin to our point with a length of 2, which is probably somewhere in here or so. Okay, but let's say we wanted to be a little bit more careful about plotting this. Well, we could think about the corresponding triangle that would have been resulted from 2 comma pi over 4. I'm going to do this over here on the side. So hopefully that looks like pi over 4. And then is what we'll have here is we'll have r is 2, right? And the question is well, what are these lengths? So that this is easier to plot. Okay? And some of you might actually remember what these side lengths are. This should be the square root of 2 and the square root of 2, right? If you were to take each one of those, square them, and then take the square root, this is going to be, 2 plus 2 in here, which is 4, and the square root of 4 is 2. So this makes sense. Okay? And then the next question might be, well, what is approximately the square root of 2? It should be about 1.4 something. So what that really means is when we go to do this, we want to go to about 1.4 comma 1.4. So somewhere in here. Okay, probably not perfect, but we're close. Again, this is 2 comma pi over 4. All right, now next, let's try this other point, 2 comma minus pi over 4. So we should do the same thing. We should rotate off the positive x-axis minus pi over 4 radians. And remember, if the angle is negative, we rotate clockwise. So we're going to be headed off in this direction, and we just need to make sure that we have a length of 2. And so what I'm going to do here is just make sure that I go out about 1.4 in the x. Let me see if I can get rid of this last dot here. Apparently not. Yeah, we'll go out in the x about 1.4, and we'll go down in the y about 1.4. So guess somewhere right in here. So this is our 2 comma minus pi over 4. Now there is something a little interesting here that we will see in the next example, but there's something interesting that we can actually see in this one. Okay, so you might have thought it was kind of a pain actually to plot these because we had to sketch that right triangle, right, and figure out what the side lengths of it would be. Well, this was challenging only because of the axes that we set up here, and this x and y axis that we're looking at here, these are really helpful if we're plotting something in Cartesian coordinates, but not in polar. Okay? And so if you actually take a peek at page 3 here, you'll see that we actually have some graph paper for polar coordinates, and this will make graphing a lot easier, because if, say for instance, we had wanted to do or plot 2 comma pi over 4, well, we just find the circle of radius 2 and the angle of pi over 4, and that puts us right here. A lot easier, isn't it? Let's go back up. There's one more concept that we want to get from this this example and example 2 kind of combined here. So this says find a few more points that lie in the same location as 2 comma pi over 4. And we're not used to this because when we think about, say, this point right here in Cartesian coordinates, this is the only point that lies at 2, 1. But this is actually not the case when we're in polar. Okay? And this isn't the case when we're in polar because, say, for instance, we were thinking about, again, this point right here. We rotated pi over 4 degrees to get there. But we also could have done a full extra revolution and still ended up here. So another point here would be, let me write it here. I want to write 2 pi over 4. What else is it equivalent to? Well, it's equivalent to 2 comma, and again, that extra revolution just meant we'd have to add a 2 pi to it, right? So that's plus 8 pi over 4. So we get 9 pi over 4. Maybe I'll actually write it here. 9 pi over 4. Well, it also ends up that we can do this a slightly different way. So we haven't discussed it yet, but you may actually already have a question here. And that question might be, well, what about if r is negative? Where are those points going to be? Okay. Well, the way that works is if r is negative, okay, you're just going to reflect, or actually I should say in an easier way, you're going to just rotate an extra 180 degrees. Okay. We actually call this reflecting about the origin, but I think it's just easier to think about as rotating 180 degrees. Okay. And let me show you what I mean here. So let's say instead we rotated to the other side here. I'm going to try and draw in a dotted line. Okay. And so here's our dotted line here and our angle that we don't really know what it is yet. But I want us to go down here to what would be approximately 2 comma 5 pi over 4. Well, if you were to just change the sign in front of that 2, is what it's going to do is it's going to take this point, and again, it's going to reflect it about the origin, which just means we are going to take this point and move it 180 degrees, which should put us back up here at this 2 comma minus pi over 4. So I'm going to actually include that here. There'll be another one. Minus 2 comma 5 pi over 4. And remember, we can just keep adding multiples of 2 pi to this pi over 4, and we'll keep ending up with points that lie in the same location. This is similar to the idea of a coterminal angle. And the same thing could be said about all these. If I add multiples of 2 pi to any of these angles, we'll end up with another representation for that point. And so that's all we're going to summarize down here. If n is any integer, the point r comma theta can be represented as blank. Let's go ahead and fill that in. So this can be represented as r comma theta plus 2 pi n. Or, all right, we saw that r could be negative. And if r was negative, all we had to do was add a 180 degrees or pi radians, and then plus 2 pi n. Okay, right? This theta plus pi is going to put us in the same location as r comma theta. And then if you want to, we can add as many multiples or subtract as many multiples of 2 pi as we want here, and it'll still lie in the same location. All right, let's try and plot one of these points that actually has a negative r here. So you can see r equals -3. So for one, even if r is -3, we still want to be 3 units away from the origin. So we're going to want to be on this circle here of r equals 3. And our angle here is 5 pi over 3, so let's go ahead and find that. So here's 5 pi over 3. There we go. So this point right here, this is, if we go back up here, it's 3 comma 5 pi over 3. But this isn't what we wanted. We wanted -3 comma 5 pi over 3. So all we have to do is just move along this line that we're already on. This is easier to see when we have graph paper like this. And again, we're just taking this point here and just reflecting it across the origin, or reflecting it across the line y equals x, or if you prefer, I prefer to think about it this way, or we're moving this thing 180 degrees. So that's going to put us right there. So this point here is our -3 comma 5 pi over 3.